In this video, we are going to see how to do facial landmark detection in just 5 lines of code in Python. So first of all, what is facial landmarks and what are its applications? So let's see, here we have face of some random person and you can see that there are some dots. So these dots are nothing but these are representing the landmarks on the face. So these are used to represent important regions on the face. For example, eyes. So we have used here some points to denote the outer line of eye. Similarly for left eye. Then we have these eyebrows. This was the lining of eyes. And here we have lips or mouth. Then we have some points to represent the lower part of nose. And then we have this jawline. If you connect all these points, you will get these. Then here we have 3 points at the top of forehead. So let's connect it. So you see, using these all points, we can outline all the major regions in the face. And this will work only for front-facing faces. These are not trained on neural networks, so it will work on front-facing faces, and that too in kind of neutral expression. If it's too much expressive, it may fail. So I hope you got the idea of landmarks. Now what are its applications? So once you have all the major regions outlined on the face, you can do multiple applications. For example, you can use it in face alignment, head pose estimation, how much head is rotated, or let's say this is rotated slightly. You can detect it. In this case, let's say this point on the head and this point, if you join it, it's like this. You can calculate the angle. Let's say if it's rotated, this will come here and this point will move here. So you can think of multiple applications, and these are not neural network based. You can do face swapping. So you have another face. You find the corresponding points in another face, and your job is to align each point on top of this one. So you can do face swapping. Then you can detect blink. So if the eye is open, these points of the eye will have some distance between them, and each point will have a specific index. Let's say this point is at index 0. This will be at index 1. This will be at index 2 and so on, and one of them will be at index 77 or 76. I don't exactly remember one of these. Let's say 78 or 77 for 78 points. So you can exactly do a one-to-one mapping. So there are multiple applications you can think of. Now, in order to achieve this, we will need to install OpenCV Python on our system. And we will also need another library called Stasm. So this is a library that is implemented in C++, but this Stasm, so originally it's a Stasm, but there is a wrapper in Python so that we can call it from Python also. So that is Stasm. So we will need to install both of these and then we are good to go. So let's begin. So here I have opened a Google Colab notebook. So I will need to import a few things. So this is OpenCV, it's a computer vision library. Then we will import Stasm. And originally it will fail because we have not installed it. And then towards the later part of this video, we will need to plot those. So for that, we will import matplotlib pyplot. From matplotlib import and it's common convention to give it a small name plt, and we will plot it here in line. So these were import parts, and I have not counted these in the 5 lines that I had mentioned here. So let's see first, if we run it, it will fail because this Stasm is not yet installed. So this Google Colab notebook generally have all the major libraries but not all. So we will need to install it first. So what we will do, in Colab notebook you will need to proceed pip install with this exclamation. On your local system you will not need this exclamation, just pip install. And it will take some time. And now it's installed. So if you run it again, it should pass. Now it's working. So you can get rid of this, or let's keep it here, it does not harm. Now we will write the main code, that is file path, or we can directly write the path. So let's read an image, cv2 dot im read, and we have an image called face.jpg in the same folder. So we don't need to write anything else. We can directly use face.jpg, and we will read it in grayscale. Then landmarks equal to Stasm dot search single img, and done. So in fact we just need 2 lines of code, not even 5 lines. Of course for plotting it here we will need many more lines, but if you print here landmarks count equal to lim landmarks. So we got an error, and it's not in the code, it's that I have written the image name wrongly. It's face 1, and now it shows landmark count 77. So it has detected all the landmarks. So this is with just these 2 lines of code. Now let's plot these points. You can leave it blank, it will use the default size, but let's say we want some bigger size so that we can plot 2 images, the original and the one with landmarks. We will need wider value for 2 images, so width is more, and then axis 1, one cross 2, and this is the first plot. And we will display in gray. And let's see what happens at this point of time. We have not yet changed anything. It's CMap. So this is the original image. We have not done anything yet. We have detected landmarks but not added some visualization for this image. So this is the original one. Next, we will apply landmarks, draw landmarks on these images using OpenCV. For point in landmarks, cv2.circle. So this is the function for drawing circle on the given image. Image this is the center, PT is the landmark point coordinates, X and Y. So next is, first is center, then radius. So radius, let's give 5. Then color. But we are displaying in gray anyway, so it will not make a difference. So if it's any color, dark color, it will show as black. Now we have drawn all the landmarks on the same image. So first we display that original image, then we update that image. You can create a new image also. And then we repeat the same thing with the second subplot. And here we go. This is the second image. So it's going out of bounds. Let's make it 16. So let's read it again. And you can see that this was the original image, and here these black dots represent different points denoting the landmarks. So we had seen that there are 77 landmarks. So there will be 77 points here. There may be some missing points if the face is not properly aligned. So I hope you find it useful and put this to some good use. You try to develop some application which uses these landmarks.